Moving on, 500 kV lightning arresters. I know that's a topic of interest for all of us.
Yeah.
So we've been, we've engaged on the root cause to understand the most recent failure. We've engaged a handful of industry experts. We're getting a common cause done by a well-renowned vendor, etc. But while we're moving through that, we did replace, the 500 kV lightning arresters in the spring with a more robust design. But until we have very high confidence that those lightning arresters will perform in the manner they're expected, without a failure. So every 3 months on an interim basis right now, we're taking the units offline and doing what we call a cold wash. Our engineering team has done their work, and essentially a 1-inch rain in 24 hours is considered enough to rinse some of the contaminants off these bushings, so that we don't have the risk. So we do the equivalent of a 1-inch rain. Okay, so the last 2 Saturdays, Unit 1 first, Unit 2 second. 2 weeks ago was Saturday. We moved last weekend Saturday to Sunday at the request of CalISO for grid reasons. We came down, took the units offline. We separated from the grid at 15%. And then we had our substation teams on standby. They went in and did a low-pressure rinse and reparalleled and brought the units back up to 100%. It was about 24 hours from 100% to 100%. We're doing that proactively to ensure that they stay in a condition where the contaminants don't that create a problem. So did that on Unit 1, and we'll tentatively we'll be doing that late August, early September. And then we'll monitor rainfalls through the winter, and if we get a 1-inch rain, it essentially resets the clock. At some point, we hope to identify the right engineering basis to say we have competency lightning arresters for a full cycle, one full refueling cycle, or we'll identify a design change that replaces these lightning arresters with one we have that confidence. But until then, we're committed to doing the right thing and avoiding another lightning arrestor failure.